Alright, that thing is drilled out now for a tap drill. The Starrett chart that I have says to use a number 7 drill bit for a quarter 20 thread. So anyway, I used, I think, a number 6. Yeah, number 6 is what I used. And that's not a whole heck of a lot larger than the number 9 that I used to drill the pilot holes with. So that went through there pretty good, but it was kind of grabby. And I'm going to have to get a full set of collets. The collet set that I have goes from 3/16 to 7/32, and the 7/32 is quite a bit too big for this number 6 drill bit. But it tightened down on it. It did spin a little bit as it grabbed in there, as the flutes grabbed in there, especially as it was coming through. But it worked. So that's all set. Now what I could do is go ahead and chamfer those holes a little bit to help the tap lead in a little bit. And they're going to have a countersink on them anyway to match up with the screws, because they were countersunk into that to get the screws to seat all the way in on that blade. So I've got a countersink here. I'm going to go ahead and countersink those holes, or just chamfer them a little bit to make it easier to start the taps in there. There's all kinds of different sizes, shapes of countersinks. 82 degrees is kind of standard. There's 60 degree and 90 degree. This is an aviation countersink, and the aviation stuff for the aviation screws and rivets is 100 degrees. So I have to check and see what my countersink is, my angle is on the screws that I got for this, to see what I'm going to countersink them at. But I'm just going to chamfer these holes just a little bit here, just to make it easier to get the tap started. Okay, I'm happy with that. I suppose I can even use this to start the taps with. If I put I've got a tap follower, or a DL spring-loaded thing to put in there. I can put the taps in there. Yeah, cool. Okay, well, this thing is coming right along. I'll have to get, again, a countersink or something and deburr the holes on the back of that, but I'm not going to do that till I take that shaft out of that chuck, till it's all finished. Well, this is the tap follower here. It fits in a 1/2 inch collet, and it's got spring loaded, so the tap wrench will go right in there. Tap wrench, a tap would fit in there, but this the smaller taps have a point on them instead of a countersink in them, so that'll go right in there, and then the spring tension will hold that against it while we turn the tap. So I'll get a 1/4 inch 20 tap those holes, but I better make sure my screws are 1/4 inch 20. Pretty sure they are. I'm on my last hole, tapping the last hole. They're all tapped but the one, and I was having a little bit of trouble with these going in. They weren't going quite as smooth as I had hoped. I'm using a tap follower there in the collet, and I was lining it up by eye, putting the tap in the hole and tapping it, but I wasn't getting them perfectly lined up. And then the torque I was for tapping was rolling the chuck around here, the tool around in the chuck. So I changed my formula a little bit. I put the lathe in B1, which is the slowest speed, 70 feet per minute, RPM, revolutions per minute. There we go. So anyway, I put that in the slowest speed, and so it's a lot tighter. It's a lot harder to turn. And then I was running the tap follower right up in and lining the hole up that way, back and forth. And that gets the hole lined up a lot better to start with here. We still wind up putting a lot of torque on it, but it doesn't turn quite so bad as it was before. Alright, I'm done tapping. Holes is done tapped. All tapped out. I was putting these screws in there to check the threads and to make sure I knew which ones were threaded so I didn't miss any, skip any or anything. Well, there we go. All I need to do is countersink, figure out how much I need to countersink each one of those. Figure out what countersink I need. I'll have to check these. I thought it'd say on the package, but it just says flathead socket cap screws. It doesn't say what the angle is on this. So we'll figure that out. It's probably 82 degrees, but we'll figure that out and get the right countersink out for that, and that one will be done. Then I can finish cleaning up the rest of that shaft. It just needs to be polished up on the other end where the bearing seat's on it, and then I can powder coat that, and that will be done. That'll be done. So I've got the blade mounted up on there now with 4 bolts to hold it steady, and I'm going to go ahead and start countersinking those holes. Now you can see here now that these screw heads don't fit flat against that blade. Well, I noticed that when I took that thing apart that the screw heads didn't fit flat against the blade. Now you wouldn't expect them to, because the holes in the flange aren't countersunk yet, so they don't fit all the way down in there, but they didn't even before. It might not be too much of a problem because the teeth on this blade are wider than the blade. The kerf that it cuts are wider than the blade, and then of course this blade never cuts all the way to the center. It can only cut maximum depth that it can cut is that flange, and that thing is actually mounted up on a bar there, so it can't even go that far. So it only cuts 4 inches deep or 4.5 inches deep. So these bolts, screw heads, wouldn't get into the cut. Or shouldn't get into the cut. But the problem is this edger blade is the lowest point on the saw. When you're cutting, it goes into the log, and as it goes into the log, you make one cut, and then you make your next cut, and so on, and it flattens out the lower portion of the log, so this portion of the edger blade would be riding on that log. Even if it didn't contact the wood underneath there, it would still cause drag and stuff going through the sawdust and whatnot. So I'm going to countersink those in a little bit deeper, make sure I get them flush with the face of that blade. So I'm going to set that up, and we're going to have a 2-step process for each one of these, I guess. I'm going to use that tap follower and then use that to line the hole up, so the center line of my drill spindle is lined up perfectly with that hole, and then I'll put the countersink in there and countersink it down, and I'll probably have to test it a few times until I get the right depth of cut. So the mill is turned off, the electricity is disconnected from it, so there's no chance of getting it turned on. We'll get it set back up again to do this operation. Just a little bit more. Just a little, just a touch more. Okay, that's perfect. Perfect or better, that's what we want. So now we'll go to the next one. Actually, I'll go 180. So we're going to keep doing the same thing, and unfortunately I wished I had another ER20 collet nut, and so I could swap these collets back and forth without having to take them all apart. I got the first 4 screws all in there, and they're countersunk down so they're nice and flush. They're just perfect. So I'll take out these other 4 screws that I put in there and get ready to do those, get those countersunk. This spindle with this countersink bit in it is just long enough that my fingers, my back of my hand hits it when I'm unscrewing these. Thought I was going to pull a fast one and go get the little electric torque wrench, the battery operated torque wrench, and undo those with that instead of doing each one of these by hand. Not that it's that big of a deal, but keep my fingers out of there from getting all barked up. But of course I don't have the right size bit for it, for the little impact driver. So I grew up doing things by hand, so it's not a big deal. Well, I got those all countersunk in there. All the screws are in. It's all mounted up good and tight. And they're all flush, nice and flush, better than they were before. So the only thing I've got left to do with that spindle, that shaft, is to deburr the holes on the back. So I think I did pretty good. Let me turn this on. Got it set up for slow. Okay. Now that blade turns just about, I mean, without putting a gauge on it and stuff, an indicator on it and stuff, and trying it, that turns just about as perfect as anybody could ask. Certainly good enough for a sawmill for woodworking. A little bit of wobble in the blade itself, but it's not in any of that that's mounted up. It's just in the blade itself. Yeah, I'm ecstatic with that. I'm just happier than heck with that. So now I can take that blade off of there and put it aside. I'm going to need to do some cleanup on the blade. I'll have to take the teeth out of there and sharpen them up and clean those up. I can see these teeth they weren't sharp and square to begin with. They need to be sharpened. Or either that or they got the edges taken off of them here. Well, anyway, that is that. I can swap this shaft end for end and polish. I'll have to polish up that other end of it where the bearing goes on and stuff, or see if I need to. And then I'm going to powder coat it, powder coat the shaft, and then that son of a gun will be ready to put back on. Oh, anyway, I'm happy. Well, I've got the shaft there for the movable edger blade put in the 3-jaw chuck, and I put the movable edger blade on there and screwed it down with 4 screws. I wanted to see, I thought I could remember those screws standing proud of that blade like the bottom edger blade did. And I've got those in there, and sure enough, they do stand proud. Between a 32nd and a 16th of an inch. It's not very much. I might just leave that one well enough alone, because that edger blade never gets in that far. Wood will never get in that far. See if it goes in 4 inches, it's right to there. That even if I make a 4-inch wide timber or something, it doesn't go in that far. So that would never enter the wood, and unlike the bottom edger blade that might drag on the log that's left underneath it, this one doesn't. It's just going to be in the free air. So I don't think I'm going to do anything with that. Well, maybe I will, as long as I've got it all set up to do that anyway. Maybe I'll go ahead and do that. I decided to go ahead and finish countersinking those holes, get those screws lined up in there so they're flush. Like I said, it doesn't really matter on this movable edger blade because the wood never gets in there close to that. But this edger blade is interchangeable with the other one, and if I ever wanted to change them, swap them from one to the other or something, then it'd be a good idea to have those in there like that. Well, anyway, I had everything all set up. I knew what I was doing. I figured I might as well do it now. Oh, now I can go ahead and take that out, put it away. This blade needs to be cleaned up too. It's got rust and stuff all over it, and it needs to be sharpened. Yeah, these blades teeth are got an angle on them. They're pretty sharp, but they got an angle on them. I guess it's got to go back together before I put it on the shaft. But the shaft, I've got to powder coat it and finish it. But I think I'm done with this for a little while. It's been raining today. again off and on, but the weather's supposed to clear up now for the next few days, so I'll get some sawmilling done and some stuff done outside now. Anyway, I'll take this back apart. The edger blade drive shaft is all finished. Got the end on it all finished up. It looks as good as it ever did, maybe better. I got it all powder coated. I didn't powder coat this is the spot here where the other bearing goes on the end. And well, anyway, this is the part that we just built, the flange. So that's ready to go, put back together. I'll take that up, put it in the basement along with all the rest of the parts for the mill that I've done so far. And it's one more thing that's ready to be put back together. So the only things I have left to do are the main shaft. I've got it in the, well, then there's a few other little parts and pieces there that need to be redone, but mainly it's almost all done except for the main shaft and the carriage. The main shaft is in the sandblast cabinet to be ready to cleaned up. I don't know when I'm going to get to it, and I'm not sure what I'm going to do with the carriage. I was thinking about just going ahead and putting it back together the way it is, but the way everything else is, I might have to get my pressure sandblaster out and clean it up and see if it needs any repairs or anything before I go. After doing all the work that I've done with everything else, I'm kind of ashamed to put that together half-assed. So anyway, we're making progress. Not going to make progress too fast here now that the weather's good, so mainly just work on this when I get a chance, when the weather's rainy, too bad to do anything outside. So, but that's good. That's done. I'm happy with that. I wished I hadn't messed it up to begin with, but it's as good as new now, maybe better.